The other day I was working on a dashboard. I wrote the core Impure script in a couple of hours, and then I just got stuck for half an hour trying to fiddle with CSS. I give up, switched to the backend, added the endpoints, queries, logic, and so forth. Also pretty quick. And then I got stuck again for half an hour trying to derive the schema for API docs. After that, I had a break and just finished for the day. I had this bitter feeling. I've done a lot, but I haven't accomplished anything. I haven't finished the task, right? Even though I was so close. I chewed on these annoying issues for the rest of the day. I hated this. I hate friction in coding. With all the meetings and firefighting, it's already a challenge to find time to code and get into the flow, so I don't want to be interrupted by stupid little things like this. Let's talk about friction. While I was chewing on this, I realized that functional programming is pretty guilty when it comes to friction. Regardless of the precise definition of functional programming, I think we can agree that it's supposed to reinforce safer code and eliminate heaps of bugs via types, abstractions, and functional design patterns. And all of this come at a cost. Look, it's the same when you want to secure your app. You add authentication authorization, MFA, VPNs, and so on. All of this add friction, but they all have a purpose. At the same time, not all security frictions are created equal, some are extremely tedious. You know that feeling when you switch from SSHing to production? 2 layers of VPNs and tools? It happens eventually at every company. Same with functional programming. Some points of friction are intentional and others are not. While outside of functional programming it's acceptable to focus only on the happy paths and overlook the rest, it's not acceptable and sometimes not possible in FP. Imagine a function that fetches a role by user ID from Postgres, for example. Somewhere in a Java land, you can say that this function takes a user ID and returns a role. Done. So 1 input and 1 output. But it's lie. What about a database connection? It is also an input. What if the user does not exist or does not have a role? In this case, there won't be a role output. In other words, 1 input and 1 output is lie. In functional land, you have to be explicit about all the inputs, even a database connection, optional outputs, and even the fact that the function needs to access the database. All of this adds friction for everybody who writes this function and everybody who uses it. But it also has a purpose, right? We want this. We don't want bugs and errors at runtime. Let's label this intentional friction. Let's say it covers types, making them stronger in static, type classes, effects, and all the other things that make a programmer's life better. And to be fair, take time to master. So by inverse, this leaves us with unintentional friction. Vague error messages, flawed tooling, missing functionality or missing libraries, and everything that makes our blood boil. Regardless of whether you agree with those categories and labels, the line between those two is blurry. Many things that are not 100% intentional introduce a friction that eventually smoothes away. It could be a small things or other ways of doing familiar things. Let's take looking for the right function as an example. It's a simple thing, we do it in every language, we all do it. However, if you're new to a language and don't know how to utilize dot completion or tools like Google, it can break your flow. You stop coding, switch to browser to search for a function, ask your colleague or wherever, you get distracted, switch to check your email or Slack notification, and then you have to invest substantial effort to get back into coding. I used to think that it's just about steep learning curves or normal hurdles for beginners or lack of skills, but the problem is bigger. For me, it's about all the things that can break the flow, and it sucks the most when various frictions interfere. Let's take an average Java developer trying to pick up a new language. I think Rust and Haskell offer similar learning curves, a bunch of unfamiliar concepts, new things to worry about, different syntax and whatever, but Rust allows you to polish down the rough corners. For instance, unnecessary cloning, dynamic dispatch, and global states are generally discouraged. However, you can quickly use this and revisit your code later, in a second pass, for example, in a second prototype, in a couple of months when you get more comfortable or whatever. Haskell doesn't let you cut corners. It's as a Haskell way or the highway. Sometimes there are many Haskell ways, but still. But it doesn't mean that Haskell is rigid or inflexible. Haskell is great for prototyping, but when you know what you are doing. Because if you're not, or returning from a big break, it's tough, not gonna lie. Even after all these years, when I return to Haskell or other FP languages, I am quite lost. How to glue the code, how to deal with errors, what to do about records. There's so many decisions and friction areas, even for veterans. I can hardly imagine how tough it must be for beginners. That's one of the reasons why people don't want to try new languages and technologies. They keep using what they know, even if it's not good, because they're already used to that friction. It's less scary than the new, unknown frictions. We talk about this a lot with one of my friends, and occasionally wonder if it wasn't a mistake for us to give up on Spring. The framework is not perfect, but it eliminates most of the decisions and discovery-related frictions, which is great. But in either case, there are still plenty of other frictions left, so what can we do? Obviously, we all want someone to work on tooling, improve errors, write books, and reduce all sorts of frictions. Usually by we mean someone else, but this is not gonna work. We should all take responsibility. And I'm not gonna ask you to contribute to open source or write books or whatever. I'll ask you to start thinking. We should be more diligent with decision making. For example, choose the right level of abstractions and fitting techniques. We shouldn't always choose based on what we want to play with at the moment, but consider the longer term consequences and the bigger picture. I can think of many examples from various communities and companies of technical decisions that added unnecessary friction and had negative consequences for maintenance, adoption, and the larger community. But those were not my decisions, and it's not for me to criticize or publicize them right now. But I have a good, simple example which I'm occasionally guilty of: the strengths of types. Imagine we have an API that returns data for all management dashboard. We just need to add how many admins we have. So how should we model it? It could be a string, an integer new type, a refined type for a natural number or something more precise. We might want to include or exclude 0, depends. We can even bring it to the type level, so we can restrict some functions from compiling when the number is 0, for example. So what type is the best? It might be tempting to have the strongest guarantees, right? But consider the volume of friction it will add for using the API, extending it, and onboarding new developers. The question is it worth it? So let's say we chose a refinement type. What are we gonna do if we start using the new storage libraries that does not support refinement type, so it doesn't have required instances? What do we do if we need to add another number, for example, for super admins and members? Do we use it? Add another one? And what if we want to ask a junior developer to update something small and they have never heard of refined types? All of this is friction. I think coding in the state of flow is great. Safe, approachable code is also great, and unintentional friction sucks. Friction can be valuable, however, reducing unintentional friction enhances the flow and increases the likelihood that people will do the right thing. This requires a lot of work and awareness, and is easier said than done. I think looking at problems from the friction point of view can be fruitful, but remember, it's not a hammer that fits all. In other words, I'm not saying that this is the explanation for everything. With that being said, let's extend the metaphor and look at 2 other things before wrapping up. A discussion about making Haskell more popular arises, multiple times a year. Every time with the same suggestions: better build tools, more learning resources and libraries, friendlier error messages, friendlier community, and all the other things that related to reducing friction. So if you ask me what the Haskell community should do to make Haskell more popular, I could say focus on whichever of these reduces the most friction, and it would probably help. However, I believe the biggest friction is in people's heads. I think it's Haskell image. The perception of Haskell magnifies its friction points. For instance, most languages have mediocre tooling full of friction, because tooling is hard. But somehow Haskell tooling is perceived to be one of the worst. So someone tries Haskell, struggles with the tooling, and instead of persevering, as they would with all the other things, they give up because that was their expectation from the start. The meme leaves and spreads. So unless Haskell goes through a major rebranding, I don't think it's going to be popular. Bite-size evolution is not enough. And should Haskell be popular? Oh, that's a whole other question. On the contrary, I'm fascinated by how blunt LLMs deal with friction, at least so far. Changed some code and broke tests? Fuck it, just delete the tests. Need a slightly different function from what the library provides? Fuck it, reinvent the wheel, copy the function, change the small thing, done. So just remove or ignore anything that's in the way. Zero friction tolerance. I think that's one of the reasons some people love LLMs and others just hate them. It is what it is.